conclude with the quotient rule. So how do we go about solving the power rule? Okay, so with the power rule, it is very simple. So when we have an equation ax to the power n, then how do we find the derivative of this? The derivative of this will simply be this n, the power, will multiply a. And then we are going to subtract 1 from the power. Therefore, we will have a n x to the power n minus 1. N minus 1, like that. So this is basically the power rule. We have differentiated this equation. For instance, we have 2x to the power 2. This will simply be equal to 2 times 2. So this 2 multiplies that. These 2 multiply. That will be 4x2 minus 1. So this will be equal to 4x, like that. It is as simple as that. Now, in discussing differentiation calculus, we have some simple terms that we have. So we've got terms like d, maybe f over dx. What does this mean? Or dy over dx. So basically, what we have is, we have a function, an equation, 2x plus 4. Now, if you are told to differentiate this with respect to x, it will be listed as dy, this is the equation y, over, what are you differentiating? You are differentiating with respect to x. So you will basically just target x. Now, once you target your x, in order to differentiate this, you are going to assume this x is to the power 0. Why? Because any number to the power 0 is 1. 1 times 4 will be 4. Now, as we differentiate this, we have a power 1 there on the 2, on the 2x. So when we cross multiply 1 times 2, we get 2. Then 1 minus 1, we get 0. X to the power 0, which is simply 1. Just like that. Now, since this x has a 0, we'll multiply. X times 0, this will give us 0. 0 times 0, 0. So this will be plus 0. So it will simply be a 0. So this will be equals to 2. And that is our derivative of y with respect to x. And so, this is what we will be dealing with. Now, there are some basic differentiations that we need to understand. Now, what are these? So, basic differentiations that we need to understand are, so we'll say function, and then we are going to say derivative this other side. Derivative, like that. So we said a x to the power n, this will be a n x n to the power minus 1. The second one we have is sine theta. This will be cos theta. Cos theta will be minus sine theta. The other thing that we also have is e to the power x. So this will simply be e to the power x. Nothing changes. The derivative of the natural log e to the power x is just e to the power x. What else do we have? We have ln x. Now what is this? The derivative of ln x is basically 1 over x. How did we come up with 1 over x? So basically what we do is, we are just going to say 1 over whatever is in the brackets, 1 over whatever is in the brackets here, by the derivative of whatever is in the brackets. So derivative of whatever is in the brackets, which is just 1 times this, then ln x is simply 1 over x, like that. All right, so now let us move on to solving some questions. What are these questions? So let us do some examples. So one example we have is 2x to the power 3 plus 4x. So we are told to simply find the derivative of this equation. How do we find the derivative of this equation? So we say dy over dx, symbolizing that we're differentiating the function y with respect to x. Remember what we learned? When differentiating, we get the power, multiply it with the number in front, power, multiply with the number in front. What do we get? 6x. We also subtract 1 from the power, that would be 2, plus 4x to the power 1. This 1 multiplies that, we get 4. This x has a power 1 minus 1, that we get 0. Any number to the power 0 is 1. Therefore, this is our answer. Okay, let us look at another example. Another example we can look at is y, or let's this time say f, is equal to y squared plus 4xy. Now you are told to find dy over dx, as well as, in fact, sorry, we are told to find df over dy and df over dx, like that. How do we go about this? Let's begin with df over dy. So this will be equals to, so basically we have y squared plus 4xy. So in solving this, what we do is simply df of dy is equal to this power multiplied by 1 in front here, we get 2y, 2 minus 1, that is simply 1. We are adding this plus. Now what do we do in this case? In this case, we are targeting simply y. So y has a power of 1. So we're going to say 1 multiplied by 4. That will be 4, right? And this 4 multiplied by x, that is x. Now what happens to y? The powers, y minus 1, that's 0. Any number to the power 0, that's 1. So this is our function, derivative of f with respect to y. Now how about respect to x? So we are going to say df over dx. So we are targeting y, we're targeting x in this case. We are targeting x in this case. So how do we do it? So simply, do we have an x here? We don't. So it is 0 plus, do we have x here? Yes, we have. So it is x to the power 1. So we multiply the power with the number in front, we get 4. Then from there, we subtract the power and we get 0. X to the power 0, that is 1. So we are going to multiply this by, the remaining is y. So we'll have y. So the answer will be 4y. And that is our derivative of f with respect to x. So this is